Hello everyone, it's Benny, and welcome back to yet another video in the 3D software rendering tutorial series. Last time, we managed to get triangles working generally, so we can specify 3 vertices in any positions, in any order, and it just works. It draws them, and everything's great. But we still don't have a good way of specifying these vertices. So say we have a triangle, let's say, hey, let's move this triangle, let's move it to the left a bit. Or, hey, let's draw the same triangle but make it a bit bigger. Or, hey, let's spin this triangle around. You know, we don't have a good way of moving things around in 3D, saying, this is the 3D position I want. So, we're going to work on that a little bit in this video. But first, there's been a slight issue with the code, actually. Since last time, someone pointed out that, hey Benny, your triangle area thing isn't actually calculating the triangle area, because the area of a triangle isn't the cross product of the two edges, it's actually 1/2 the cross product of the two edges. So, yeah, we're going to need to change that. But since we're not really caring about the actual triangle area, we're just comparing it as a greater than or less than 0, I'm just going to rename the method to triangle area times 2. And it's as simple as that. So we rename it, we change how we use it, there we go, we're done. So that solves that issue. So now there's the issue of how do we specify triangles generally? If we look at our code here, I mean, we can specify their positions just fine, but you know, how can we take into account all the different things we'd want to do with it, so like all the different positions and whatnot. And the answer is pretty much the same answer you'd get if you're doing this with hardware accelerated graphics like OpenGL or DirectX or what have you. And that is, you're probably going to want to use vectors and matrices. It's just a really easy way to do that. And as far as I know, there's not really a much easier way to do it. And in fact, they're so similar that I have taken the matrix class and the vector class from the 3D game engine, and we're going to be using those. And I'm not really going to go too in-depth in that, because I did cover it in the 3D game engine series, so if you're interested in how you can do it with matrices and vectors, you can look in that series. But yeah, I'm just using this, so this is the matrix class, pretty much identical to how it was in the 3D game engine, with minor modifications, like, say, we're not using quaternions and stuff anymore, so there's that. Vector class, almost exactly like it was in the 3D engine series. Only difference, really, is I made a vector 4 because we actually are going to be using this 4f component, so it's vector 4f. And of course, no more quaternion stuff. And there! So you can download, you can change it yourself, it's very easy changes, or you can get it from the GitHub repository. So with that, let's start making some slight changes so that everything can use the vectors and matrices to transform stuff and move it around. Now, the only change we really need to make is in vertex. Rather than using an X and Y position, which we don't need anymore, we're going to use a vector 4f. So if I have a vector 4f, I'm going to call impos for position. And rather than setting it like this, I'm going to change that around. So now it says impos, new vector 4f of x, y, and nothing in the other two. I don't care about those for now. Although, I am actually going to set w to 1. But other than that, I really don't care about it. So, with that should be okay there. And now I need to replace everywhere it says mx with impos.getx. Okay, so I went ahead and did most of the work off-screen because it really is basic refactoring. The only really interesting thing I did is I got rid of the setters, because we're actually not going to need the setters anymore. We're going to be doing all our changing vertex positions, moving vertices around, with matrices. So I'm going to create a new function in Vertex. It's going to be public vertex, so it's going to return a vertex, and it's going to be called transform. And it's going to take in some matrix 4f, transform, and yeah, this is how we're going to move everything around. Now, if you look in the matrix class, I'll try to show you this on screen. So if you look in matrix, scroll down, keep scrolling down, you'll notice there's a transform method. And this is what we're going to be using to move stuff around. So, if I go to render context, if I go to vertex, we're going to be using transform, and we're going to be essentially feeding it in position, and it's going to be that simple. So that's how we're going to transform it. And yeah, it really is that simple. This will perform a matrix vector multiplication between the transform matrix and the position matrix, and that'll give us the new position we want, well, for the vertex. Now, keep in mind, this is returning a new position. This is not changing in position. So what I'm going to need to do is I'm going to need to actually create a new constructor. So, yeah, one that takes in a vector, if I can spell it. There we go, vector 4f. I'm going to call it pos. And I'm just going to set impos equal to pos. There we go. And yeah, I'm just going to say return new vertex, taking in transform, dot transform impos. There you go. Simple as that. So now we got our vertex class, we can move stuff around, and it's great. It really is that simple. And this will allow the entire transformation framework that I showed you how to create in the 3D Game Engine series to just work with the software rendering series. So if you really want to, you can go ahead and import the transform class, the quaternion stuff, and it'll all just work. So that's kind of nice. But there are still a few things we're going to need to do in our software renderer itself to take this into account. So, how do we take into account all the matrix transformations that might be happening with our vertices? Find out next time on the 3D software rendering tutorial series. I realize it might not seem like we accomplished a lot in this video, but we just laid the framework for a full general-purpose transformation system. And the power of that is not to be underestimated. So, thank you, hope you enjoyed, hope you learned, and I'll see you next time, where you will witness the power of this fully operational transformation system. Thank you, see you then.